Hello everyone. So let's continue with section 13.4. So when you start with section 13.1, you introduce two linear equation in two variables, x and y, and you learn how to graph it by using the table. You set up the table, you pick up the point, you get the coordinate of the point, you connect all the points together to get a line, right? The line could be slanted upward or it could be slanted downward, but you don't know exactly how much it is slanted. Okay, from the equation you don't know exactly how much is slanted. Today in this section I will be talking about another form of linear equation, and in this form it will tell you exactly, okay, you can read it from the equation, it tell you exactly how much the slant is going up or how much the line slanted going down. Okay, and you can it will also help you to find the value, and that value will tell you exactly how much the line will be slanted, okay, given 2 points. Alright, so let's get started with the topic today. Section 13.4. Okay, the topic for section today is sloped, okay, and rate of change. Okay, maybe some of you already you already been familiar with this term, slope and rate of change. Some of you is not. That's okay. I'm gonna be talking about slope, and I will tell you exactly what it is. Okay. But before doing that, okay, I will introduce you another form of linear function or linear equation. This is called slope-intercept form. So slope-intercept form. The form we learned last time, ax plus by equals c, we call the standard form. Okay, and this form we call slope-intercept form. And what is slope-intercept form look like? The slope-intercept form is y equal to mx plus b. While you look at the problem, you see that, oh, why so many variables? But you also see that there are x and y over here. Okay, m and b is very important number. M we call that the slope. Okay, and b we call that y-intercept value. Okay, from the b you can write a y-intercept point. Okay, for example, I have this linear equation like this: y equal to 2x plus 1. Then m will be equal to, right? Slope will be equal to 2, and the y-intercept value, the b equal 1. Okay, maybe some of you asking me, kind of wondering, okay, I mentioned about slope, but what is slope? What is slope? The slope will tell you exactly how much slanted the line will be. It could be slanted upward, it could be slanted downward. It depends on the slope also. So it depends on the m value. Okay, if m value is positive, you know that it's slanted upward, the line. If m is negative, the line will be slanted downward. Okay. So graphically, slope will tell you how much slanted the line will be. Okay, how much slanted the line will be. And it has another name. Okay, it also has another. Because slope has, it could be called rate of change. Why we call it rate of change? The rate of change of what? Rate of change of what? It's a rate of change. Okay, it's a rate of change. It's the ratio. Actually, I think I'm gonna fix it later. I need to correct it later. So slope is the ratio. It's a ratio. It's a rate of change, but it's also a ratio between the change of y, okay, over the change of x. I know that some of you still really confused right over here. What is this change of y? What is this change of x? You know. Okay, let's make it clear. Okay, now let's draw a line. Let's draw a line. I have a coordinate system like this. Okay, and I'm gonna pick a point. Okay, I'm gonna pick a point over here. Point 0, 1, so 3. Will be 0, 3. So point B here. Okay, let's name it. And I pick a point over here as -2, and I call it point A. And I connect these two points, A and B. So you see that my line over here is slanted upward. It means that my slope is positive. M is positive. Okay. But over here, I also say that slope is the change of y over the change of x. Change of y over the change of x. Okay. Over here, I have point B is 0, 3. Okay. Okay. Look at that. It goes from 0 to 3, right? So, do you see the change in y? You start from the origin, and you go from 0 to 3. Okay, and similarly, you start from the origin, you go from 0 to -2. So from this concept, okay, from this definition, I can say that slope is equal to, okay, is equal to what? It will be equal to y2 minus y1 over x2 minus x1. Okay. Okay. With y2, y1 is the y component of point A and B. x2 minus x1 is the x component on point A and B. Okay. So point A has coordinate given. Point A coordinate is x1, y1. And with point B is coordinate is x2, y2. Okay. Okay. Or we can read the slope by another way. We can read the slope by rise overrun method. Rise overrun. It means what? It means that it goes. You see that it starts from here. Okay. You start from the y. I'm sorry. You start from the y-intercept value. Is that? you going up how many units? Okay, you going up like 1, 2, 3 units, and you going to the right 2 units. Okay, then you know right away the slope in this case will be m will be equal to what? Rise 3, going to the right 1, going to the right 2. So the slope over here will be 3/2. Or if you use this concept, y2 minus y1, you can also get the m. Okay, so m can be calculated by using the y and x component upon a and upon b. So upon a over here is what is the coordinate upon a? The coordinate upon a is -2, comma 0. The coordinate upon b is 0, 3, right? And you see that y2 will be what? The coordinate upon b will be coordinate upon b or coordinate upon a, doesn't matter. So I'm going to say y2 is coordinate upon b, so it will be 3 minus y1 is coordinate, y component upon a is going to be 0 over 0. x2 is component upon x2 is component upon b, right? X1 is x component upon a will be -2. So you see that it still gives you 2, 3/2. So there's 2 ways to calculate the slope. So there's 2 ways to tell how much slanted the line will be. Or there are 2 ways to tell you if the line is slanted downward or if the line is slanted upward. 2 ways. The first way is you can read directly from the graph using rise over run method, and you start from 3. You start from the y-intercept. Or you can use the slope formula. So this is the slope formula. Okay. But if you use the slope formula, you have to pick 2 points. 2 exact points. Okay. Otherwise, the question must give you 2 points. Then you can calculate the slope. Alright? Then you can calculate the slope. Alright, so that is the case. That is the case when you have the line slanted upward or the line slanted downward. What if I have horizontal line? What if I have horizontal line? What if I have something like this? What if I have something like this? This is y equal 2. Then what happened to the slope? Any horizontal line, remember, any horizontal line, the slope will be 0. Okay. Then what is the case when we have vertical line? What if we have vertical line? Something like this. 4, x equal 4. Then do you think that the slope will be 0? No. In this case, we don't have slope, so undefined slope. Slope is not 0, okay? It's undefined slope. It means that we cannot find the slope. Alright, we cannot find the slope. If at the horizontal line, we can find the slope. Okay? So you see that if it is the question give you the linear equation in slope-intercept form, then you can read the slope right over here by look at the m value. Okay. However, if the question give you the standard form, the 1ax plus by equals c, then you cannot read the slope directly, right? However, you still can get the slope from that equation by doing some manipulation. That is what I'm gonna show you right now in example 2. I think I'm gonna put example 2. So this is example 1. Okay. Okay. In example 2, I give you a linear equation like this. It's in the form ax plus by equals c. A over here is -2, b is 3, c is 11. So by looking at this, you see I don't know what the slope is. And because I don't know what the slope is, I cannot tell how slanted it is. Right? I cannot tell. Okay. But if I can convert it to slope-intercept form, then I can tell how slanted it is, right? So how we gonna convert it? So in order to convert this, you're gonna leave all the term with y to one side on the left hand side, and you're gonna move all the term with x to the right hand side. So I'm gonna move it to the right hand side. I'm adding both sides by 2x. So I'm gonna have something like this. Right? Everybody know how to do this. We already learned how to solve a linear equation. Okay, isolate the y term and put the x term to the right hand side with the constant. Okay, then we need to get rid of number 3 by, so how am I going to get rid of number 3? I'm going to divide both sides by 3. So I'm going to get y equal to 2 over 3x plus 11 over 3. You see that? This is y-intercept. This is the slope-intercept form right here. This is slope-intercept form right here. It means what? It means that I can get the slope m will be 2 over 3. I know right away that because this is positive. So I know right away that if I graph this line, it's kind of going upward. It's going upward. Okay. I know b is 11 over 3. B is y-intercept value. But from B, I can get the y-intercept point. In order pair will be what? Will be 0, 11 over 3. Because it's y-intercept, the x component will be 0. Okay, so remember that. If I ask you to find y-intercept point, you have to write in order pair form. If I ask you to find the y-intercept value, you just need to write b equal a number. Okay, so that is the way how you convert between standard form and slope-intercept form. Alright. Alright. Let's see what else. Let me give you another example how to find slope given 2 points. Actually, I already give you the example right here. Actually, I already show you how to do it over here. You see, I already show you how to do it over here. But I think I'm gonna give you another example. Okay, I'm gonna give you another example. All right. Find the slope given 2 points. Okay. The first point is point A is 2, -1, and point B is -3, 1. You know, if they give you the graph, basically, you just pick 2 points, 2 exact points on the graph, and you apply the slope formula. Okay, so this is the slope formula. This is the slope formula. I boxed them. Okay. All right, so I'm gonna use slope formula to find slope. So m will be y2 minus y1 over x2 minus x1. And some of you hadn't memorized it, so you just label. So this x1, y1, x2, y2. So y2 will be negative 1, y1 is minus 1, right? And x2 minus x1, x2 could be what? x2 could be negative 3 minus 2. So negative 1 goes to be 0 over negative 5. So over here the slope over here is 0. It looks like that the line of this slope will be horizontal line. And that horizontal line will go through the point negative 1. Okay, it goes through the point negative 1. Alright, so that is the way of finding the slope, graphically or using the slope formula. Okay, I think we're gonna add a little bit more. So this is when you have slanted upward. Oh yeah, I already wrote it down here, so that's good. So over here m equals m greater than 0, so it's slanted upward. If it go this way, then m less than 0 is slanted downward. Okay. Alright. Now next, what if I have two lines? Okay, what if I have two lines on the coordinate system? Okay, and those two lines parallel to each other. Those two lines parallel to each other. So we have parallel line. Okay. Something like this. Something like this. Graphically, I'm gonna have something like this. I have a line like this, and I have another line like this. And I say that these two lines are parallel to each other. Okay, I cannot draw perfectly, but just assume that it's perfectly parallel to each other. Okay. Then what happened to the slope? If they parallel to each other, okay, if they parallel to each other, then the slope will be the same. M1 equal M2. Slope the same. Are the same. Okay. It means what? It means if I know the slope of the first line and I know they parallel to another line, then I will know the slope of the second line. Okay, then I will know the slope of the second line. If I know the slope of the second line, then I will know the slope of the first line. Basically, they're the same. Okay, they're the same. Now, what happening if those lines are perpendicular to each other? Yeah. What if they perpendicular to each other? So what if they have something like this? I have a vertical. I have one line like this, and I have another line kind of like this, and a perpendicular right here. So let's call this line L1 is L2, and this is L1, this is L2. So L1 perpendicular to L2, and this is L1 parallel to L2. If L1 perpendicular to L2, then the product of their slope will be equal to -1. Usually in high school, your teacher show you that if you had a perpendicular line, then the slope of the new line will be negative reciprocal. You remember? So actually it comes from this. You see that from here I can get M2 is -1 over M1. See, negative reciprocal of the slope. Then you can get the new slope. Okay, then you can get the new slope. All right. For example, What if I have the first L1 y equal to negative 2 over 3x plus 1? And I know that, so this is L1. Okay. And I know that L1 perpendicular to L2. Okay. Then the slope of L2, I'm going to call it M2, will be negative reciprocal of this. Negative reciprocal, negative become positive, so reciprocal make it reciprocal, so it will be 3 over 2. Okay. If it L1 parallel to L2, then M2 will be negative 2 over 3 also. And because it's perpendicular, so you make it negative reciprocal. Actually, it comes from this. It comes from this. The product between two slopes of the line, perpendicular line, equal negative 1. Over here, parallel, the slope will be equal. So I'll just box it. Okay. Alright. So there is a very important concept you guys must know. Why so important? Because when you go to intermediate algebra, you will see that again. You go to college algebra, you see that again, and you keep seeing that, and you see that many students do have trouble with it. So I want you to learn this carefully. Okay, I want you to learn this carefully. Alright, so that when you go to higher level, you don't feel awkward. Okay, because you already learned this. Okay, so whatever you learn, you have to learn carefully. Okay, so let's see what else. Otherwise, we're gonna stop right here. Okay. Yep. So basically, that's all. That's all information you need to know in this section 13.4. If you have any concern on this section, please let me know. Okay. Other than that, I will see you next time. Bye bye.